So we are going to discuss about the Faraday's law, the Maxwell's equations from the Faraday's law. First of all, you must aware about the Faraday's law. That is the Faraday's law. It should be equal to the rate of change of flux with respect to the time. That is the electric potential is developed in the changing magnetic field. So the V it should be equal to minus d pi by dt, right? Minus d pi by dt. So again, if you are consider the number of turns n in the coil or winding, so V it should be equal to minus n into d pi by dt. That is another one relationship. So we know the relationship from the electric field and as well as the potential. V it should be equal to the line integral of E into dl, right? V it should be equal to the line integral of E into dl. So both the V we can consider, but according to the Gauss law, the pi it should be equal to the surface integral of total magnetic flux density. It should be equal to the flux. Okay, so that is the we written the expression from the Gauss law, pi equal to surface integral of d into ds. If you want, you can check it in your notes. So the derivation of Gauss law, you may see the same expression, pi equal to the surface integral of d into ds. Okay, so just you can replace in the pi in terms of the surface integral. So the minus d pi by dt, the same thing. Then instead of pi, you can substitute the surface integral of d into ds. Just you can replace it. So here, so we know the another one equation, that is the V it should be equal to line integral of E into dl. Then V it should be equal to minus di by dt into surface integral of d into ds. You can compare the equations. If you want, you can put the equation A and the B. So you can equal both the equations A equal to B, because the LSH side both are in the V. So you can equal both the equation. So the line integral of E into dl it should be equal to minus d by dt into surface integral of b into ds. It came. So so you can the differentiation you can here it is the commonly, as per the expression, the equation, the d by dt is the commonly written outside. So here the integral term is there. Just you can move the inside of the integral term. However, you need to make the integration of the flux density. Just you can move in the integral inside of the integral. So the minus surface integral of dou b by dou t into ds, right? Dou b by dou t into ds. So that was the expression. Then another thing, you know the relationship between the electric flux density and the electric field intensity. That is the B equal to mu into H. So here it is the magnetic flux density. Again you have written the same expression in terms of magnetic field intensity. So you can write like that. So here the line integral is there, but here it is the surface integral. So it means that this is the integral form of this expression is in the integral form of this, both the expression is the integral form of the Maxwell equation, right? So you can apply the Stokes theorem here. The line integral it should be, you can convert as per the Stokes theorem. The line integral can be converted into the surface integral like that. So you can convert it, and you can write instead of EDL, in the line integral of EDL, you can just replace this expression. So the surface integral del cross E into ds, it should be equal to minus mu into the surface integral of dou h by dou t. So that we can written from the previous expression. So both the side the surface integral was common, you can eliminate it, and del cross E becomes minus mu into dou h by dou t. That is the point form of the Maxwell's equation from the Faraday's law. Okay, the del cross E it should be equal to, again the same relationship. Both the equation are the differential are point form of the Maxwell equation from the Faraday's law. Okay, that is the point form. If they are asking the integral form, before applying the Stokes theorem, you are obtained the expression, that is the integral form of the Maxwell equation from the Faraday's law. So it means that you have derived both the integral form as well as the point form of Maxwell's equation 2. Okay, that is the equation 2, that is the Faraday's law. Okay, thank you.